Hello there, welcome to another video on logarithm. In today's lesson, we are going to solve more past questions on logarithm, and at a point, I'm going to focus more on logarithm that involves simultaneous equations. But before we do that, let's look at this question. This is from February March 2024, variant 1 2. So, this is the same as 12a. There's minus a minus becomes division divided by 6 to the base p. So those of you that think that the base is always base 10 or base 2, be careful. It can be a letter, it can be anything. Okay. Now on this one, the coefficient becomes the power. So this should give me, my friends here can cross out. So okay, this is the same as 2a is equal to 64. Okay, now the reason why I'm starting with this question, there's an important concept here that you should know. Now, you see, what we have done so far is that we have expressed our logarithm as a single log expression, single logarithm. Okay, now if you have single logarithm on the left and a single logarithm expression on the right, you can find what you call the antilog. You can take antilog of both sides. Take antilog of both sides. So what that means is that you can actually cancel your logarithm alongside its base. So your logarithm and its base will go away. Okay. So that's the anti-logarithm. So right now it's left with your argument. So you can equate your argument. You can only do this, you can only take log of the anti-log of both sides if you have single logarithm expressions. Don't forget that. Then here you can divide both sides by 2, and that should give you 32. Okay, let's move on to the next question. Find the exact solutions of this equation. Here, this is the same as 4 log x to the base 3. This expression we can change to base 3, and this is the same as 1 over log x to the base 3. Let's log x to the base 3 be m. So this is the same as 4m is equal to 9 over m. Let me multiply throughout by m, and let's see what will happen. So I'm getting something like this. And this is the same as, I'm going to divide both sides by 4. When I do that, I'll get this. Okay. And so I have m squared is equal to 9 on 4. I'm not done. I can find square root of both sides. This will give me plus or minus 3 on 2. Don't forget your plus or minus, otherwise you get it wrong. But we are not done. Don't forget that you said m is equal to log log x to the base 3. So let's take the positive value first. Oh, okay. If I take the positive value first, it will be 3 on 2. If it's the other way around, it will be negative 3 on 2. So either of these is correct. Yes. Let's move on to the next question. Okay, I have a question here. We are so used to logarithm to other bases, but you're not used to len. Remember that I said in my introduction, the first video, that log of any number or letter to the base e is the same as len. Okay, so this is the same as logarithm to the base e, where e is an irrational number, which is 2.71823. A lot of numbers. It's an irrational number. Okay, but you don't really need that. All what you need to know is how to solve questions that involves this Euler's constant, or what people call the exponential function. Now, let's look at this. So, let's call this one. This can be written as the first one. Equation 1. The second one here, I want to make x the subject. If I do so, I'll have 1 minus ln y. We call this equation 2. So let's put 2 into 1. So if I do so, I'm going to get 5 times x. X is 1 minus ln y. So this should give me this. Now these are like terms, so I can subtract them. This is the same as negative 8 ln y. Okay, so I make this one come here. So I get 3 is equal to, then I will make this one go to my right. So 8 ln y. This is the same as this. Is equal to 3. I just switch them. So there's nothing new here. At this point, don't forget that your coefficient will become your power from the power rule. Then here, I try and write it in the index form. Okay. So here, the base will carry the power. The base is what? E. So it will carry the power. This equal to this. Okay. I could have written like this. It's equal to, more suitable, right? Then what can I do here? So I want to find the value of y. So I can multiply the power by its reciprocal. Let me do so for this. So this is the same as y is equal to, this and this will cross out. The 8 and 8 will cross out. So this is the same as y is equal to e to the power 3 on 8. So that's the value for y. You can leave your answer in the exact form. Nobody will do anything. As a matter of fact, they even prefer it when you leave your answer in the exact form. Now, you left with the value of x. So from equation 2, we say x equal to 1 minus ln y. Your y is what? E to the power 3 on 8. Okay, so this is the same as, you know, your power will jump down and become your coefficient. Do you remember that? And ln e is the same as logarithm to the base e of e. And we learned that any logarithm to the same base is what? 1. Do you remember? Yes, so this expression goes to 1. So you get when you solve this, you get x to be 5 on 8. 5 on 8. I told you it's not difficult. Up to now, you still don't believe me. All right. So let's move on to the next question. So we have a logarithm question here. All right. Log of the expression log x to the base 2. Yet we have log s to the base 2. Okay. I can see a trend here. Here we have log y to the base 2, log y to the base 2. All right. So since they have the same log expression, the two equations have the same log expressions, I can do something. I can say let log x to the base 2 be a, and let log y to the base 2 be b. Okay. I can only do this because when I look at the two simultaneous equations, I have both expressions here. I have log x to the base 2, log y to the base 2 in the first equation, the second equation. That's what I mean. So in that case, I can represent it with a letter. So when I do that, I'll get 3a plus 2b is equal to 24. Equation 1 from this one. Then I can also get, for the second one, I'll get 5a plus, no, it's minus 3b is equal to 2. Equation 2. Okay, so let's solve this simultaneous equation and see. Um, let me go for my favorite highlighter or marker. Um, let me multiply this equation by 2. Let me multiply this one by, no, let me multiply by 3. And let me multiply this one by 2. I believe you can solve simultaneous equations. So I did that because I want to get 6b plus 6b and minus 6b. And I know that we can solve them by elimination. Because when I get 6b and minus 6b, both of them are the same variable. Just that the operations are different. So if I add them, I'll get rid of them. So I'm using elimination method. So if I do that, I'll get 9a plus 6b is equal to 72. Let me call this one equation 3. Then the second one, this will give me 10a minus 6b is equal to 4. Equation 4. Okay. Now let me add equation 3 and 4 and see what will happen. This will give me 19a. This and this will subtract. This will give me 76. So let me divide both sides by 19. When I do so, I'll get 4. A to be 4. from equation, let me count for equation 2. It looks equation 2 has smaller values. 5a is 4, minus 3b is equal to 2. Okay, so this is 2. When this one comes, it becomes 20. So minus 20. So 2 minus 20, which is the same as negative 18. So if I divide both sides by negative 3, I should get 6. So b is 6. But we are not done here. Don't forget that you define your logarithm. You said a is the same as what? Log x to the base 2. So we had a to be 4. So if I write it in the index form, I'll get x to be equal to 2 to the power 4, which is the same as 16. Then when we have log y to the base 2 to be b, your b is what? Your b is 6. So yes, so if I come and find the value of y, I'll get this. And this is the same as 64. So the good news about logarithm is that you can actually use your calculator to confirm your answer. So now let me take you through it quickly. I'm going to write these expressions. We had x to be 16 and x to be to the base 2 of 64. Why is 64? Y, not x, y. Okay. You see, we are getting 24 here. Okay. It's a simultaneous equation. So the first equation must work. The second equation must also work. Let's come for the second equation and see. Don't clean everything. You just need to clean the numbers. 5. The operation is minus. Replace the 2 with 3. And yes, we are good to go. Let's see whether we get to. If we get to, that means you are right. Wow, we are right. Okay, so you can see we are in a comfortable lead. So you shouldn't get your answers wrong, never. So if you're able to do this, you get 5 marks. Let's look at another question. Let me see whether I have any question like this at the top. Okay. Okay, so this is a simultaneous equation question. I think we can do that one too. And this one too. Let me see. This question number 4. It was question number 4 in the exam, but this is question number 8. Okay, I'll answer this one last. So now let me take this one. Okay, so we have log of the expression x plus y to the base 2 to the base 3 rather is equal to 2. Uh, so this is the same as 3 to the power 2, which is what? 9. Equation 1. Let's see. Now, on the other hand, I have 2 log to the base 3 of x plus 1 is equal to log to the base 3 of y plus 2. Now, before I can solve this one, I have to express it as a single logarithm on both sides. So the coefficient becomes the power. Okay, so you can see I have a single logarithm on the right hand side, on the left hand side to have a single logarithm expression. So at this stage, I can take logarithm, anti-logarithm of both sides. Take anti-log of both sides. So that means I can cancel my log along with its base. In other words, I can just equate the argument. Okay. Let me move to my favorite. Let me move to my favorite blue ink. It gives me good luck. So let me use that one. Okay. So let me call this equation 2. Um, can I say that x is equal to 9 minus y? Let me call this equation 3. Okay. So put 3 into 2. You say x equal to what? 9 minus y plus 1 all squared. Now this is the same as 10 minus y all squared is equal to y plus 2. Now if I expand this, I'm going to get a quadratic. I'll get 100 minus 20y plus y squared. And this should give me y squared minus 21y plus 98 is equal to 0. Okay, let me take my calculator so that I can move very quickly. I'm going to solve the quadratic. 1, negative 21, the next number is 98. X equal to 14, x equal to 7. Okay, good. Don't forget to write your linear factors, okay, because they'll be checking. Sometimes they award marks for it. So even if you use the calculator, don't forget to write the linear factors. All right, so y is equal to 14 or y is equal to 7. But we are not done. It's a simultaneous equation, so we have to find both x and y. So when y is 14, let's see what you get for x from this equation. Um, x will be what? X will be negative 5. Okay, interesting. When y is 7, let's see, x will be 2. Okay, now when you finish, you're supposed to make sure that your answers are correct. It could be that one of our answers is not correct. Um, okay, so if I put 2 here, uh, okay, 7. So you can check the calculator and see. I think that this one will be disqualified because if I have negative 5 here plus 14, yes, I'll get log to the base 3 of 9, which is 2, which is correct. However, let's come to the second place and check. Negative 5 plus 1. That will be log 2 log to the base 3 of negative 4. So this answer is wrong because you said that the argument must be what? Must be greater than must be greater than 0. Okay, so this one is wrong. So it's not part, it shouldn't be part of your finances, your final answer. So in conclusion, you have to conclude that x is equal to 2 and y is equal to 7. Well, if you don't conclude in this question, you lose a precious point. Let me see whether there's okay. Let's solve the one at the top, then we close for today. So let's look at the last question for today. I have this question, a question from 2020, October, November. I always give my students this question in the exams. All right, so I hope that they are not watching so that they will not hear. So log y plus 1 to the base 2 is equal to, then I also have this log expression. Okay. This is the same as log 2 to the base 2. You know, this is the same as 1, right? This is the same as 1. So 3 times 1 is the same as 3. So 3 can be written like this in this case. Okay. And so I'm going to get, so when 3 becomes the power, I'll get 8 minus, okay, and I can express them as single logarithms on both sides. So it's minus, so the argument will divide. So since I have a single logarithm expression on the left and the right, I can take the antilog of both sides. So I'll just equate the argument. Okay. So y plus 1 is equal to this. Okay. Let's come to this side and see. This is also the same as 2 can be written as log 2 to the base 2 times 2. Yeah. And this is also the same as, when the 2 comes here, you get 2 to the power 2, which is 4. Okay. All right. So since my logarithm have the same base and they're adding, I can express them as a single logarithm. So I have this. So here too, I can take logarithm of both sides, the antilog of both sides. So I'm going to get x plus 2 is equal to 4y. Equation. Let's call this equation 2. Let's call this equation 1. Okay, so this is what I'll do. I'll take equation 1, I'll multiply it by 4. If I do so, I'll get 4y plus 4 is equal to 38, 32 on x squared. Don't forget, you say that 4y is equal to what? This expression is that is x plus 2. Okay, this is x plus 2. So this is the same as x plus 6 is equal to 32 on x squared. So can I put this one in the bracket? So let me multiply both sides by x squared. So I'll get this. If I do so, I'll get this. Okay. And this is the same as x cubed plus 6x squared is equal to 32, which is the same as this. Let's go and see whether it is the same expression that we have here. Oh, okay, it's correct. 4 marks. Well done, well done, well done. So I think we should end here today. We have solved a lot of questions on simultaneous equations involving logarithm. If you enjoyed this video, don't forget to tell your friends about it. Don't forget to share it with your friends in other classes, in other schools. I will see you in the next one.